Welcome back to G Fun Facts Online, your go-to source for the most exciting bites of science and tech. Today, we're diving deep into the atmosphere to talk about something called atmospheric rivers, or ARs for short. Now, these aren't your everyday rivers flowing on the ground. Imagine massive, invisible rivers of water vapor, thousands of kilometers long, flowing high up in the sky. For places like the US West Coast, these ARs are a double-edged sword. They're absolutely critical, bringing much-needed rain and snow that replenishes our water supplies. But, and it's a big but, they can also unleash devastating floods when they make landfall with too much intensity. And with climate change potentially making them stronger and more frequent, figuring out when and where these atmospheric behemoths will hit is more important than ever for managing our water and keeping communities safe. So how do we get better at predicting these powerful weather events? Well, folks, we're on the cusp of a new era in AR forecasting, and it's all thanks to an incredible partnership: artificial intelligence, or AI, and Earth observation, or EO. It's like giving our weather forecasters superpowers. Let's break it down. Earth observation provides the eyes in the sky and on the ground. We're talking about a constellation of advanced satellites like a NOAA's GOES series, those geostationary sentinels watching over us, and polar orbiting satellites like the Joint Polar Satellite System, or JPSS. These incredible machines continuously monitor things like water vapor content, cloud structures, and other key atmospheric variables in high resolution. But it's not just satellites. We also have ground-based observation stations and even specialized reconnaissance aircraft missions. These planes fly directly into atmospheric rivers, deploying instruments called drop sondes, which parachute down, collecting vital data from within the storm itself. Think of it as a weather probe dropped right into the heart of the action. Now, all this data is fantastic, but it's an asterisk lot of data, terabytes upon terabytes. And that's where AI, particularly machine learning and deep learning algorithms, steps in. These AI models are like super smart assistants that can sift through these massive datasets, identify complex patterns, and track ARs with incredible speed and accuracy. In some cases, AI is even outperforming the traditional numerical weather prediction models we've relied on for decades. Take Google's GraphCast, for example. This AI model has shown some truly mind-blowing accuracy in making global weather forecasts up to 10 days out, and it's particularly good at spotting ARs that could lead to flooding. Then there are specialized AI models like ARDetect, which uses deep learning, a type of AI inspired by the human brain, to segment images of ARs. It can pinpoint the exact shape and location of an atmospheric river with high accuracy, and it does it much faster than older methods. But it's not just about being faster, it's about being smarter and more precise. Researchers are now developing hybrid forecasting systems. These clever systems combine the strengths of the physics-based numerical weather prediction models, which are great at understanding the underlying atmospheric dynamics, with the pattern recognition prowess of data-driven AI techniques. The result? More detailed, more localized, and more accurate forecasts. We're seeing improvements in forecast accuracy for certain variables by as much as 10 to 20%. That might not sound like a lot, but in the world of weather forecasting, it can mean an extra 1 to 2 days of warning before an atmospheric river makes landfall. That's crucial time for communities to prepare. High-resolution modeling is a big piece of this puzzle. Imagine trying to predict a weather system over the entire Pacific Ocean versus zooming in on the specific path an AR will take towards the coast. Scientists use something called nested grid approaches in their forecast systems. This allows them to run highly detailed simulations for specific regions of interest, like the Eastern Pacific and the continental US. Of course, running these super detailed models requires immense computational power. That's where facilities like the AWARE system at the San Diego Supercomputer Center come in, providing the horsepower needed for these high-resolution ensemble models and for training the latest AI algorithms. AI is also transforming how we use the observational data itself. Traditionally, data from satellites and other sources needs to go through a complex process called data assimilation to be incorporated into forecast models. But new AI-based regional forecasting models are being developed that can, in some cases, make predictions directly from the raw observational data. This can slash uncertainties and boost forecast accuracy, especially for short-term predictions. Looking ahead, the developments are even more exciting. Scientists are training AI and machine learning models with data generated from these new, nested, high-resolution models. The ultimate goal? To create AI systems that can directly replace some of the most computationally expensive parts of our current atmospheric forecasting systems. This would drastically cut down the time and cost involved in predicting ARs and assimilating data. And the research doesn't stop there. Another big challenge is improving what's called subseasonal-to-seasonal, or S2S, prediction of ARs. We're talking about forecasts weeks to months in advance. This is incredibly difficult because of complex climate interactions and limitations in our observational networks. But AI models, with their ability to handle vast amounts of data and untangle complex, nonlinear relationships, are uniquely suited to tackle these long-range forecasting challenges. So to wrap it all up, the fusion of artificial intelligence and Earth observation is truly revolutionizing how we predict atmospheric rivers. This powerful combination is leading to forecasts that are more accurate, arrive sooner, and provide more actionable information. This is absolutely vital for protecting lives and property from severe flooding and for better managing our precious water resources, especially in a changing climate. As AI algorithms get even more sophisticated and our Earth observation data becomes richer and more accessible, we can expect even bigger leaps in our ability to predict and prepare for these impactful weather phenomena. That's all the Fun Facts Online we have for you today. Thanks for tuning in, and be sure to join us next time for another exciting dive into the world of science and technology.